All right, welcome everyone. Today's topic is all about why projects fail, and essentially an overview on this topic called operational readiness, often abbreviated as OR. So let's take a look at some very famous project failure quotes that have been generated over the last few decades. The first one was a study done in the 80s, which looked at 35 Australian gold mines and found that over 2/3 failed to deliver on the planned production. So whatever they were targeting in terms of tonnage and ounces of gold was not able to be delivered. And even worse than that, only 10% actually achieved whatever their commercial planned output was. So very low numbers by any stretch of the imagination. The next one was from mining.com. And they also showed that globally, 2/3 of mining projects face what they looked at specifically was cost, and they face cost overruns. There was another one by Ernst & Young, which looked at just mega projects, so very large, multi-million, maybe even billion-dollar projects. This report looked at about a little over 100 current mega projects, different geographies, different commodities, industries, and again, they were looking at money in this case, so they were looking at budget overruns. We're in that sweet spot again. 2/3 showed, 62% showed as having cost and budget overruns. And then perhaps the worst of this slide is PricewaterhouseCoopers. Back then looked at different projects, and only 2.5% of companies actually delivered their projects. If you look at many different factors, if you're only looking at cost, maybe the numbers are slightly better. But as soon as you combine deadlines, costs, scopes, benefits, that number drops to only a couple of percent. And it makes one wonder. We've been doing projects for thousands and thousands of years. You figure we'd be getting very good at creating products from mega projects. And yet these studies show that we're actually not very good at it, despite all the new technologies and new techniques we have for project management. So let's take a look at why that is. If we look at critical causes of project failures, these are some of the things, some of the areas that are the most critical, right? You start with things like technical and supply issues. Handover and startup is another one, looking at risks, safety, health, and environment. Maintenance and materials often go hand in hand, strategies, budgets, planning, and monitoring. So you get the idea. There's quite a few things one needs to look at in terms of projects. What one notices when you do work with people who are in this world of projects, most of the energy is usually spent in the first two bullets. So most of the energy, if you imagine a construction company or an engineering company, a technical company, will look at technical issues. What are some of the technical challenges, whether it's equipment or whether it's corrosion issues, for instance? And supplying. How do we get the supply to give us the equipment, give us the products that we need in time for when we need it? What the studies have shown, however, is that most of the project failures do not occur in the first two bullets, possibly because most of the energy goes there, right? Because there's so much energy that in this study by, again, PwC, only 8% of project failures were actually because of pure technical issues or pure supply chain issues. The bulk of the reasons why we have project failures are actually associated with the bottom half or the bottom 3/4 of this slide. And if you group them up, that 92% is really about management. It's about managerial. It's about project management. You get that idea that it's not really technical issues. It's more of a management issue. And this is where operational readiness comes into play. So what is this word operational readiness with this term? It has obviously two words that are very easy to understand. We want to be ready for this thing to be operational. But what exactly does it mean? And it means different things to different people, but we'll take a look at some of the more common definitions, right? So one of the definitions is it's usually a capital project, something quite intensive with a lot of money. It could be an asset. It could be a specific equipment, like a large pump or a large generator, for example, that you're putting into place. Is that thing able to be delivered and capable of having a nice startup, a nice ramp up, and give us sustainable production? So effective startup means I want to turn it on a certain day. and I'm able to get material going through it or energy coming out of it, whatever the case may be. Ramp up usually has some kind of definition on paper. We want it to go from, for example, 20% production to 80% production in 1 month. So that's what I would like to see in terms of a successful ramp up. And sustainable. So obviously, once I turn it on and once I start getting up to this ramp up and I hit that 80 or 90%, can I maintain it? Can I sustain my production operation? Another definition is a little simpler, is it should function as intended. I bought something, I paid money for this thing to do something for me, and maybe create products or package things or generate pounds of material. So I want it to function as intended when I start it up. And the tail end of that phrase is also just as important. I need the right people to run it, okay? It's all about being ready to operate. So I need the people first, and I need the people to be properly trained so they know what they're doing. Another definition is to increase the value, right? That's part of the reason you're doing a project. You're increasing the value in delivering the product or the service throughout different systems, different processes, different procedures, whatever you may have in your company, while simultaneously minimizing risk. So minimizing risk is a big part of operational readiness. Some of the work you do as an operational readiness lead and team is to say, right, we're going to make sure this thing works. We're going to make sure we're ready. However, what if? What if it's not working properly? What if it's not going to give us what we want when we want it? How do I minimize that risk? And do I have a mitigation plan? Do I have a plan B? I need to have a plan B, especially if it's a critical element. Independent person or team to represent the needs of the client and work with the project team. Okay, what does that mean? I'm often asked this question. What if you really want operational readiness to work? This concept of independence is very important. It doesn't have to be an external person from the company. It can be an internal person, but someone who can stand independently from both the engineering company and from the client. And why is that? Because half the time you're pushing and you're looking at the engineering team or the construction team saying, look, this is what our expectations are. This is the timeline we need. This is the quality that my client expects. You're kind of challenging that relationship. I think most people understand that role. What people forget is the other half of the time, an operational readiness lead and team is looking the other way, is looking towards the client and challenging the client, saying, are you ready for when this thing is turned on? Are you ready? Are your people ready? Do you have the infrastructure? Do you have the manuals? Do you have the training? Not just the manuals. So an engineering company will give you the manuals, for instance, and some rudimentary training, but that's not the same as having people who truly know how to run the process. That's totally different. And that is the responsibility of the client. Just like many other things in this world, if you're thinking health and safety or ISO, you cannot treat operational readiness like a checklist. This is something that is real, something that has to have depth and information in it. And you have to make sure people buy into the concept. Otherwise, it doesn't really add value to your organization. So what does it look like? So when you picture operational readiness, let's say picture a capital project, picture it as having different pillars, right? These green areas. If you look at it from the top, the 12 o'clock mark on the clock and going clockwise, you have things like, what are the operational strategies and the budget? What is the scope and the tracking we're going to do with this project? Who are the people associated with this project? What's the management going to look like? Tie-ins and handover. Tie-ins is more if you're dealing with, for example, a brownfield project where you're linking with something that already exists. How are you going to add this new thing to this old existing thing? Risks and contingency planning, I mentioned the importance of that. Health, safety, and environment, and maintenance and materials. Those are the big buckets, the big pillars. And then you notice inside that loop is a smaller loop called define, plan, and execute. Why is that? The reason it's there is because the activities that happen in each of those boxes actually get repeated 2 or 3 times. You're going to look at a lot of these at the define phase. I just want to define the strategy, for example. Then it's about planning. Well, how are you going to be planning the work? What are the steps involved to get that strategy to actually work? And then you're going to execute against that strategy. And most of these pillars, most of these buckets have that loop effect, right? You're going to be touching them at least once, twice, or maybe even 3 times throughout the life of the project. So especially with mega capital projects, ideally you want this operational readiness activity to start at the very beginning, maybe a year, year and a half, even 2 years before you go live, if you truly want to get quality from this approach rather than just at the very, very end. This is a little bit more detail for those of you who are interested. So I'll cover, I'll go through this a little bit in some of the main bullets. So the first one, operational strategies and budgets. So what does that mean? So you see the word obviously called strategies. You can take a look as well as operating budget. So eventually when you're going to run this plant or this operation or this asset, what is that going to look like? What is the budget going to look like? What is the operating budget? What is the maintenance budget? Do you have a training budget? Has anybody given thought to actually not the high-level engineering cost of building the thing? How are you going to run it? And what's it going to cost to run it in detail? Second one, scope and tracking. So this is the scope and tracking of the operational readiness work, not of the engineering work. We already have an engineering team doing what they have to do. This is the scope of work of operational readiness. What is it going to look like? What are we going to be doing in order to do commissioning properly and testing? How are we going to train the users? How are we going to monitor and control? And very important, how do we integrate these operational readiness activities into the project schedule? We don't want them to be totally separate where we're working in a vacuum. We want the two to work in parallel. Ideally, the operational readiness schedule actually gets embedded into the project schedule, ideally, but it doesn't have to be. Manuals, procedures, documents, that all falls into this pillar. People and management. So who are part of your team? Who's going to be part of this OR team? How are we going to do communication? What is the training going to look like? The idea of an end user, the idea of the final people who are going to be using this equipment or this operation. How are we going to make sure that they know what to do and how to do it, right? You want to integrate into any of the existing production controls and quality management systems. So if it's a company that already has these things, either at site or in corporate, you want to make sure that this project actually blends into these systems. You don't want to have your own system. Tie-ins and handover is one that I found in my experience to be very critical and very important. So you want to start understanding what are some potential interferences, shutdowns that we have to do in order to blend in the new thing to the old thing, tie-ins. What are those performance tests going to look like? How are we going to do the handover? Okay, it's easy to say we're going to finish this project on a certain date. How exactly is the handover going to happen? How is the engineering project team going to hand over the keys to the operation people? Commissioning is part of this as well. An assessment of how ready we are. This gets done throughout the life of the project. At the beginning, obviously, it's more rudimentary. And then as we get closer and closer to go live and startup, then we want to make sure we're ready and that we have backup plans in case it's not working properly. Risks and contingency planning, we've touched on this as well. So we want to do a detailed risk analysis. We want to have contingency plans. We want to be able to mitigate. You can't mitigate everything. Obviously, this is not about having a huge laundry list of hundreds of activities that we need to mitigate. But the ones that are critical in terms of maybe affecting the bottom line of the company or health and safety or environment, anything that has a criticalness to the activity should have a backup plan. Health, safety, and environment. So what are all the possible impacts? What are they? Have they been evaluated? Beyond what the project team looks like, you're also looking at the eventuality of having to turn this process on. What is that going to look like for our day-to-day operations? And then finally, maintenance and materials. So you want to plan things like automation, the IT, communication, the maintenance, reliability. All of that gets done in here. It's kind of a very high-level explanation, but you have to remember the purpose of operational readiness is I want to be ready for everything. So if part of the everything is I need offices and desks and chairs and phones and radios, then that has to be part of our list. Someone has to do it. The engineering team may not be on the hook for that. So how are you going to make sure you have proper work environments for the people you're about to hire for this eventual process, right? All right, that leads us into something related to point estimates. So when we do have a failed project, the center of this graphic, it's usually one of a few things, right? It could be because of delays, which is time. It could be cost overruns, which is money, or poor quality. Obviously, quality is in there as well. There could be other reasons, client needs not being met. Maybe the market's not happy. If you promised that you were going to go live on a mega project on a certain date, and you happen to be a few months late and a few tens of millions of dollars too expensive, the market's not going to be happy. Your city's not going to be happy. Your community's not going to be happy. Or the scope is not being delivered. What you promised us is not going to be delivered. Not only are you late, and not only are you costing more money, you're not going to give me what I asked for, which is even worse. So what does that mean? What we end up doing is we end up blaming usually one of four groups. We blame the construction group or construction company. Perhaps we blame the engineering company and how they set up the estimates or set up the plan. Maybe the labor itself, the people who were involved with the work and with the construction, for instance, or the client. Maybe the client dropped the ball and they didn't do what they were supposed to do to get ready for the process, right? So the top part of this says, if you sort of embrace operational readiness, if you believe in it and you put it in place early enough, it will definitely minimize the probability of having these failures. It even gives you mitigation backup plans, right? It's not foolproof. It's not going to be a miracle. So there still can be issues, but it definitely does minimize this probability. The question here is, can we still have a problem? Even if we implement operational readiness, could we still have a problem because of the way estimates are generated? And the brief answer is yes, and I'd like to show you what I mean by this. So point estimates, what does a point estimate mean? It means if I'm talking about money, I say $1 million. If I talk about time, I say 1.2 years, all right? These are point estimates. It's just a single number, and it could deal with finance, it could deal with time, it could deal with labor. They're dangerous for a lot of reasons, right? Early in the project, you probably don't have enough information to state cost, for example, with high certainty. And when you say a number like 1 million, it makes it sound like you have a very, very good handle on the number, that it's a certainty that it's going to cost that amount of money. The one that I've seen time and time again is when you're presenting this to management, I like to use the word hypnotize. You're hypnotizing management into believing that number. So once you've mentioned that million or 10 million or 100 million, they will anchor themselves to that number and they will hold you to it, even if it was just an estimate with a range. It hides the estimation of financial failure. I don't know what this range is because you just gave me a single number. And it doesn't really provide information on the reality of the variation that is associated with this number, because all you gave me is a single number, right? And worst of all, you and your team, if this is your team, your project team, or your operational readiness team, you yourself will start anchoring yourself to these numbers. So it can be very dangerous to the likelihood of success of your project. So what is the solution to this problem of point estimates? And the solution is Monte Carlo and Monte Carlo simulations. Often people get a little bit scared with the term because of the word simulation, but it's very, very simple to use. And the simplest one is this one on the slide called the 3-point estimate. 3-point estimate is using triangular distributions. It's very common, it's relatively simple, and it's super powerful. And what you're doing is the same spreadsheet you're using to figure out how much time it's going to take or how much money it's going to cost or what is the payback of a project. The spreadsheet is the same, but what you're doing is every number has the range associated to a minimum, maximum, and most likely. So if we're dealing with cost, minimum would be maybe an optimistic view of the world, and maximum would be a pessimistic. And then the most likely is not average. The most likely is your best guesstimate as to what the number should be. That's your most likely outcome, right? And what usually happens is a triangle like you see there at the bottom right. It usually has this off-centered, unbalanced triangle. Because if you think of something with a cost, I will buy an expensive piece of equipment at 100,000, and I ask, well, what's the lowest you think you can get it for? You may be able to get a sale, or you may be able to get a little bit of a price discount and say, well, maybe I can get it for 90 grand or 85 grand. But if I ask you what's the worst, it says, well, hang on a second, that could be really bad. If we have problems with supply chain or things exploded in terms of the need for this equipment, maybe it can be as expensive as 150. So that triangle is usually has a skew to it on the negative side. Okay, this is very typical of when you do these kind of simulations. And what you're doing is each input in your spreadsheet, imagine you have 10 inputs you're adding up for time or for money. It's the same 10 inputs, but now you have a min, max, and most likely number. And the software, all it does is it takes a point randomly inside that triangle and will repeat it over and over and over again to give you a better view of reality. So what does that mean? What that means is, imagine for a second that instead of me saying to you, the project will be completed in 34 weeks, I give you this instead. So I give you a nice looking graph, which represents these thousands of simulations that I've run based on all the min, the max, and the most likely. This gives you now the power to interpret exactly what you're going to be getting in terms of variation, in terms of likelihoods. So now you'll be able to say, well, when Carmen said 34 weeks, there's actually only a 20% chance of doing it that quickly, okay? There's 80% chance that it will take much, much longer than 34 weeks, perhaps as much as 40 or 42 weeks. So now it depends. If I'm trying to plan for having the right labor and I need subcontractors here on site to be ready for you when the plant goes live, I may use the 34 weeks. I may actually use the 32 weeks because I want to be sure that my people are here in time for you to go live. On the other hand, if I'm making a plan for when I will be able to start production or when I will be able to start producing money for you, to my client or to my boss, then maybe I'll go the other way. I said, well, actually, it's more likely than not that I need about 40 or 42 weeks in order to get this project ready to go live, basically to start up. It gives richness of discussion and richness of information once you have built in this very, very simple min, max, most likely, and we can have a conversation. So I can have a conversation with the client, or I can have a conversation with the leader to make sure we're making the right decision based on this probability distribution. The main takeaway here is that you need three real components to success. Is you need an operational readiness system, you need to understand risk, and preferably not use single points. Use this idea of a range or a min-max most likely. If you combine these three things properly, you now have an increased likelihood of success. Just as a wrap up, the idea here is what we do at Analyze and Improve is we try to give a customized approach in trying to understand and solving the issues, whatever your problems or opportunities are. So when we're dealing with mega projects, when we're dealing with operational readiness, part of the idea here is we need to understand what the risks are. Once we understand the risks, once you can start quantifying these risks, then you're able to give a plan. You're able to make sure that the client, in this case, has a good chance of being operationally ready, so that when the plant goes live, when the production goes live, when the thing starts, there's a good probability that it runs properly, on time, and on schedule, based on the needs of the client. And the other element I wanted to mention is because this gets asked quite a bit, there is the ability, of course, to do assessments, operational readiness assessments. And ideally, of course, like anything else in life, you want to do this kind of work, you want to do these type of assessments early in the process. So imagine you're starting this project and you're doing it a year before going live or starting up or whatever the number may be. And that has the most value. It doesn't mean that you can't do it late. We have been called many times to do assessments a month or two before the startup. It's limited in value, and the limitation is that if there are any gaps, it's hard to resolve it in such a quick amount of time. What you can do, however, is any of the key gaps, you convert them into contingency plan. So we don't have time to fix element A, B, and C, but we should have a backup plan just in case those things don't work, and that way we have mitigated the risk and put the odds in our favor. So I want to thank you for your time. I will stop sharing the screen and open up this presentation to any questions or issues you may have. Okay. All right. Any questions? Thank you for that.
Yeah, maybe on the Monte Carlo, I can talk to, because I can hear. Let me turn my camera on.
Yep.
So on the Monte Carlo, you mentioned, it's easy to just convert everything to 3 columns, and then get the answers in certainty. Is there like, would you do that in the early stage of the operational readiness or throughout the operational readiness? Where's the best bang for the Monte Carlo analysis?
Yes, I would say it's like the assessment answer, right? As much as possible, early is best, because what ends up happening, there's a few problems, right? When you wait late, usually through the life of the project, you have more and more complexity in the spreadsheet. I've done it for large projects, mining projects, for example, where it's about finances. And when you wait too long, now you have a monstrosity of a spreadsheet that you need to try and convert into a Monte Carlo tool, right? So earlier is best. The other element, Asim, which I'm sure you've seen many times before, is when you're not using it early, then you start embedding things like buffers and extra line items at the bottom end, which are needed. You need those discretionary amounts at the bottom, but the discretionary amounts on the bottom is just more for things, you don't know what you don't know, so you slap on 15 or 20% at the back end, but you still need that range per element. So usually you get richness in quality and a little simpler life when you do it early as opposed to do it at the very, very end.
Okay. Yeah.
Yes. Plus, you have the added benefit when you do it early is that you don't have, like, min-max most likely is just one way of doing it. If you have the historical data, you could use, a normal curve or some other distribution that you already have data for, which makes it even more powerful than just min-max most likely.
Yeah. Thank you.
Yeah, you're welcome. Any other questions? Okay, thank you very much for your time. As with all of our Lunch and Learn webinars, we will be saving this as a video in our YouTube channel. So you're all welcome to share in it. And that is it. Enjoy the rest of your day. Thank you.